Good morning, everyone. Again, online students, we are now in our second lesson or lesson 2 of Science 7. So let me share my screen. Where's my screen? Wait. Mixtures, elements, and compounds. Let's have this one. Right, mixtures, elements, and compounds. Let me have it this way. Access it using my phone. It's lagging. Heterogeneous and homogeneous mixtures. Can you say it clearly? Wait, let's move this one around. Okay, heterogeneous and homogeneous mixture. Okay, a mixture is a classification of a matter. It consists of 2 or more components. If it is a mixture, it is a classification. We classify mixture based on what we actually see. Okay, because again, it is composed of 2 or more components that are not chemically combined and are not in any fixed proportion. Okay, each component of a mixture retains its characteristic properties. So if, okay, you see a mixture that doesn't contain or doesn't chemically combine, when you say chemically combine, the atomic particles of those certain elements combined. Like for example, sure, what does it mean? Like for example, you have sodium chloride. Is sodium chloride a mixture or a compound? When you say mixture, you can actually see them and they are not chemically combined. But if it is a compound, it has or it actually mixed chemically or they're combined chemically. Okay? Sodium chloride or your NaCl or your salt is a compound. Sure, why? Because they are chemically combined. So the molecules or the atoms of sodium was mixed with chlorine or chloride in order to create NaCl or salt. So those are just few. Let's tackle that one later. Let's have heterogeneous mixtures. When you say heterogeneous mixtures, these are lessons from grade 6, by the way. Okay, these are lessons from grade 6. The introductory lesson of heterogeneous and homogeneous mixtures are from grade 6. Right? Heterogeneous mixtures are composed of different substances that remain physically separated. Okay, or remain physically separated. You can actually see them separated. You can actually see the different components. Do you have your notes with you? Okay. When you say heterogeneous mixtures, these mixtures composed of different components that you can actually see. Okay? They are physically separated. Okay? They always have more than one phase. Okay? Each has region of uniform composition and properties. Because again, you can see layers in them. Okay? Again, this topic was exhibited last science exhibit by grade 6. Okay? They have heterogeneous and homogeneous mixtures. Again, as what I'm telling you a while ago, the heterogeneous mixtures are composed of different substances or different components, which is physically separated so you can observe them. Okay? The oil in water mixture is also a heterogeneous mixture because again, oil is immiscible to water. Okay, miscibility. If it is liquid to liquid, okay, it is miscible and immiscible. Liquid to liquid, miscible and immiscible. Okay. Solid to liquid is soluble and insoluble. Okay. Heterogeneous mixtures could have two or more phases which are in liquid state. Okay. For this to happen, the liquid components of a mixture should be immiscible. Okay. Immiscible, unable to mix. Okay. When you say immiscible, that certain component will not mix with the other liquid component. That's immiscible. Okay. Immiscible to mix with other liquid in the mixture. Other examples of heterogeneous mixtures are, you look at the one, sand and water. That's solid to liquid. Okay. Because you can observe sand and water. You can observe the different components. Solid. Okay. Solid to solid. Right? Different fruits. Concrete. Solid to solid. Okay? Vinegar and oil, because you cannot use or you cannot mix vinegar and oil. Okay? Just like your seasonings. Okay? Liquid to liquid. Common table salt and pepper. Salt and pepper will not mix. Of course, you can actually observe them. What else? Sand and iron filings. You cannot actually mix sand and iron filings. You can actually observe them. So those are some examples of heterogeneous mixtures. Okay. Do you have any questions so far with heterogeneous mixtures? Okay, let's move forward. In most cases, the different components of a heterogeneous mixture are visible to the naked eye. Some of them are visible to your naked eye, meaning to say that you can observe them. Okay. However, in some cases, you will need tools like microscope or a magnifying glass to identify the different components of a mixture. Okay. Some of them are microscopic. Right? It may appear a homogeneous mixture, but under the microscope, you can observe them, so they are heterogeneous mixture. A suspension is a heterogeneous mixture consisting of solid particles that may remain suspended momentarily or dispersed throughout a liquid by mechanical agitation or shaking. Okay, one another term of shaking, mechanical agitation. Okay, after some time, the particles settle at the bottom of the container. Okay, that's a suspension. Let's take a look at the different examples of suspension later. An example of suspension is cornstarch and water. So when you mix cornstarch and water, it may appear inhomogeneous, correct? Because they will mix with water. But then again, what? After some time, the cornstarch will remain at the bottom of the container. Because again, that certain mixture is suspension. Okay? When you pour cornstarch in container with water and shake it, the cornstarch particles will temporarily remain suspended in water because of agitation, mechanical agitation or mixing or shaking. Okay? Suspended in water and the mixture appears cloudy. But when you leave the container for some time, or an hour, okay, it will be suspended at the bottom. The cornstarch will eventually settle at the bottom of the container. Okay, meaning to say that that certain mixture is a heterogeneous mixture because you can identify the different components of it. Right? Do you have any questions so far? Question. Some medications are in suspension form. Thus, you see the instruction, shake well before using in the packaging. Okay? So some of them are in suspension form. Like for example, the medication for cough. Okay? Some of them are in suspension form. So there are particles settling at the bottom of the container. So what should we do? We need to shake it well. That's mechanical agitation. Shake it well in order for the mixture to mix thoroughly on the what? On your medicine. Okay, that's the reason behind. The following are properties of a suspension. Number one, consists of an insoluble substance dispersed in a liquid. We say dispersed, scattered in the liquid. Okay. Second is, it is a heterogeneous mixture. Third is opaque or not clear. It's not clear, so it's opaque. Okay, cloudy in appearance. That's being opaque, right? The third one is particles settle after a time. So when you leave that certain mixture, some particles will remain suspended at the bottom of the container. Simon, are you still with us? Simon?
Sure.
All right. Let's move forward. There are mixtures that may appear homogeneous, yes, but when observed through a microscope, okay, they appear heterogeneous because the components are microscopic. An example is a mixture of sand and sugar. Sometimes you cannot observe it with your naked eye. Okay, when you mix sugar, the tiny bits of sugar, crush it over and mix it with sand, you cannot actually identify that there are some sugars there. Okay? Unless you're using a microscope to identify the crystals, the sugar crystals. You need a magnifying glass, of course, to identify sand grains and sugar crystals. So those are just a few. What else? What are other examples? Sometimes also you cannot actually observe that there are some salt in your sugar. You mix salt and sugar, you cannot actually observe it by your naked eye. Especially if they're really small. What else? Iron filings and sand. Sometimes you cannot observe them, especially if they have the same color. Okay? Homogeneous mixtures. Okay. Homogeneous mixtures are made up of two or more substances, same with your heterogeneous mixture, but they spread out uniformly, okay, and look similar in appearance and composition of your mixture. Okay, if you divide homogeneous mixture in half, the same amount of component is found in both halves. Okay, meaning to say that if you have a 1 liter of that certain mixture, okay, and you need to divide it by half, 500 ml, the same amount of the components are in those 500 ml. Okay, that's a homogeneous mixture, meaning to say that the components are evenly distributed. Okay, one good example is your salt solution. When you mix salt and water, okay, when you mix salt and water, the salt will eventually spread out in the entire solution, leaving your solution a homogeneous mixture because you can actually see only one. You can only observe water in it because the salt is evenly distributed, or the salt dissolves in water evenly. That's one good example.
About water and milk powder.
Water and milk powder. Okay, how about water and milk powder? Is it a homogeneous mixture or a heterogeneous mixture? Who says homogeneous? Who says heterogeneous? Who says heterogeneous? The answer is heterogeneous. Water and milk? Water and milk?
Yeah.
Okay, can you observe milk in your water?
Yes.
How about if you leave the milk for some time? What will happen?
Mix of the time.
No, it will not mix. If you leave, Milk and water? Huh?
No, that is
Some of you will really like to, leave your milk aside for a minute or an hour because you want those salts from the milk. You want those suspended particles, correct? You want to collect those suspended particles. So we have suspended particles there. Therefore, milk is a heterogeneous mixture. Okay. Let's move forward. Homogeneous mixtures are also referred to as a solution. So there are another terminology, solution. What's with the solution? Okay. A solution consists of liquid called solvent, okay, where substance called solute is being dissolved. So let's unlock this terminology. When you say solution, it is composed of solute and solvent. What is solvent then? This is the dissolving agent. You say dissolving agent, this is the one who will dissolve those particles. That's the dissolving agent. Okay. How about solute? This is the one being dissolved in a solution. Like for example, let's go back to the first example. Water and salt. Where is your solvent in water and salt solution? Where is your solvent there? Water or salt?
Salt.
Solvent? Water or salt?
Water.
Water. That's your solvent. The one who dissolves in the dissolving agent in a solution. And the solute there is your salt. Because that is the one being dissolved in that particular solution. Did you get the point? Okay. Let's move forward. Common examples of homogeneous mixtures or homogeneous mixtures are soda. There are soft drinks. Another term for soft drinks are soda. Mineral water. Mineral water is still water. Yes, it has a lot of components. Okay. Air. Air is a homogeneous mixture without dusts. But if you're gonna mix it with dusts, it will become heterogeneous. Salt or salt water. Why? Because the salt there is being dissolved in the water, evenly distributed. And alloy. Okay, it's the mixture of steel and bronze. Alloy metal. That's homogeneous because you cannot identify where the steel is and where the bronze is. Let's move forward. Separating components of a mixture. Okay. The components of a mixture can be separated through physical means. Okay, since they are not chemically combined. Okay, the different substances in a mixture can be separated from one another by taking advantage of their properties. So how can we maximize the separation of this using their properties? Unique properties. What's with these properties? So let's take a look at this one. Decantation. Okay. The sediment particles in liquid is called sedimentation. Okay. Sediments or sedimentation, it varies with the flow of gravity. If the heaviest particles settle first and the lightest last, right? If you pour the liquid out of the bottle, leaving the heavier particles inside, you do the process called decantation. So you are actually pouring. Other term for decantation is pouring. Like for instance, if you have a mixture of oil and water, remember that oil and water don't mix, correct? Because they're immiscible. Oil is immiscible to water. So what will happen next? So there is some floating oil in your container. All you have to do is to decant. Decant is to pour. So you just pour the oil from the top, okay, leaving water behind. So meaning to say that you separated, okay, you separated oil and water by decantation. That's how we perform decantation. We usually do that also in our laboratory. Okay? Sometimes we tend to separate mixture using decantation.
The decantation is all the oil butter.
Other term for decantation is pouring. You just pour. Simple. Okay. The lighter one will be poured out, and the heavier one will remain in the container. Simple. Nothing more, nothing less. Mechanical separation. So what is the mechanical separation? Okay. Suppose you have a mixture of chocolate chips and cereals, and you want to separate them. Because you can actually identify them, correct? Cereals and chocolate chips. Since the components of mixtures are large enough, okay, it is easy to separate them manually by picking. That's mechanical separation. You just pick and separate them. Okay, mechanical separation. Filtration. Okay, we're almost time. Let's continue. Start by identifying the property of sugar and sand does not have. So you may say that sugar dissolves in water, correct? And sand does not. It will not dissolve in water. It is insoluble to water, correct? Sand is not soluble to water because, again, those are fine particles of what? Of soil and rocks. Okay? Thus, you need to filter through which the solution will pass, leaving behind on the filter paper. The process of separating solids, okay? The process of separating solids from liquid, okay, is called filtration. Okay? Again, the process of separating solids from liquid is called filtration. So, for example, we have a mixture of mixture of sand and salt or sugar. So all we have to do is to mix, okay, sand and sugar with water, because water has a property that is soluble in, or sugar has a property that is soluble in water. Correct? So we need to take advantage of that property in order for us to separate, okay, sand and sugar. So we need to dissolve the sugar on water with the sand, of course, and use filtration in the process. We can filter, again, the sand because it's too large. It is insoluble in water, so we can filter them out. After which, we have now, what? A solution. A solution. You already solution. What? A solution of water and sugar.
That's why you separate water and sand.
Yes, we have now the complete sugar. So how do we separate the water and sugar? By the next slide. Okay. If you put seawater, okay, in an open container and leave it mixture under the sun, the water evaporates in a process called solar evaporation, leaving salt particles behind. Same process as how we can extract the sugar in our sugar solution, the one we actually filter. Okay, we filter out sand, correct? The remaining ones are water and sugar. So how can we separate water and sugar? By means of evaporation. We'll put it on heat. Yes, Krishna.
Sure, is evaporation not salt?
Yes, this is how we create also salt. Rock salt. Your rock salt. Remember that your seawater is a composition of, or has a composition of, water and salt. So how can we separate water and salt? By evaporation.
They leave it out in the sand and then after they get small particles and that's rock salt.
Yes, that's how we create salt. By evaporation. So we separated water and salt in the process. Sure, how? By solar evaporation. Some of them, they want it as fast as they could, so they create salt in the laboratories by boiling them up, vaporizing water, and the remaining ones are the salts. That's how we create salts. That's how we separate also sugar and water in the process by evaporation. Again, we need to take advantage of their unique characteristics. Distillation. Okay, the best way to separate the components of a mixture composed of two liquids. Again, mixture that composed of two liquids with different boiling points is through distillation. Okay, we have boiling points. Water has a boiling point of how many degrees Celsius? How many degrees Celsius? When will your water boils?
8:30.
20 degrees Celsius. You don't know? Water boils at 100 degrees Celsius. Water freezes at 0 degrees Celsius. The refrigerator must reach 0 degrees Celsius, your freezer, in order to freeze your water on your freezer. Okay? You cannot boil a water unless it reaches 100 degrees centigrade or 100 degrees Celsius. Those are their unique characteristic. That's the unique characteristic of water. Okay? The liquid with the lowest boiling point is collected first by using evaporation and condensation. So, like for example, how can you separate a mixture of alcohol and water? Okay. Alcohol and water. Okay, by distillation, alcohol and water. Okay, so how? Sure. How can we separate alcohol and water? Remember that the boiling point of your water is 100 degrees Celsius, correct? The boiling point of alcohol is 85 degrees Celsius. So we can separate the alcohol and water by distilling it or distillation. So we will let the mixture reach 85 degrees centigrade or 85 degrees Celsius. Okay, letting the alcohol evaporate, okay, and condense on the container, dripping it over. Once it evaporates, the remaining component there are entirely water because all the alcohol already evaporated. So that's how we separate water and alcohol because they have different boiling points. That's one characteristic of alcohol and one good characteristic of water. Right? Do you have any questions so far? We will try to separate liquids. We will also to separate these components or mixtures. Hopefully, if we have the luxury of time. Okay? Because this should be done in the laboratory. Paper chromatography. Okay? Homogeneous mixtures, okay, that are composed of solvent and one or more solutes or dissolved substances are often separated by chromatography. So how can we do chromatography? In chromatography, various materials of mixtures are selectively absorbed in a column or strip paper. So we need to put strip paper. Like for instance, the mixture of water and your ink. How can you separate water and ink? So by boiling. Okay, when you boil, what will happen? Your ink also will go along with your water. So you cannot separate them by evaporation or distillation. This is by through paper chromatography. How? We will dip again a paper, okay, a column or strip of paper on the solution. Eventually, your ink, okay, will be attracted to the paper, and eventually we can separate water and ink. Okay, the components are then separated on surface container. Okay, surface such as your paper. So that's how we separate water and ink. Do we still have time? Okay, I think we don't have the luxury of time. Let's continue by next meeting, but we need to finish this one. Paper chromatography is used to separate components of ink and food dye. Okay, it consists of stationary phase. Okay, take a look at this one. Stationary phase is solid like absorbent paper or a liquid, and immobile phase, okay, a liquid or a gas which flows in the stationary phase and carries the mixture with it. How can that be possible, sir? So sometimes separating them is really crucial. So we need a stationary phase, a solid container, okay, or an absorbent paper, and you need to run something on it to make it more absorbent. Okay, that's how we do paper chromatography or chromatography alone. Okay, let's continue by next meeting with centrifugation. Okay, because you don't have time, it's already, let me check on my watch, 11:08 in my watch. Do you have any questions so far? Questions so far? How about Simon? Do you have questions so far? Simon?
Okay.
Okay. By the way, yes, Simon. All right. By the way, the slides that I have here is downloadable. So this will be considered as your notes, right? You need to download those. How to study science, again, highlight the important details. That's how to study science. And do not memorize, familiarize them. Right? That's how my grade 7 class do science. We are serious with what we are doing here. Right? I want you to learn science as easy as possible. That's the easiest way of learning science. Do not memorize, familiarize. Right? Download the slides that I have here. I prepared this one for you. Okay. I think that will be all for today, class. Please stand for the prayer. This course, I will just inform your advisor. Right? I'll be checking all of those, recorded one, and I will give them to your advisor.
In the name of the Father, the Son, and the Holy Spirit. Amen. Thank you, Lord, for helping us and getting us to learn new information today. And hopefully, Lord, we will learn more in the future. Hopefully, we do get passing scores and everyone will pass. And in Jesus' name we say, Amen. Father, and the Holy Spirit.
Thank you, my class.
Bye.
Again.
Goodbye.
Please take your